I left only one model like this to utilize the model. I will return run once more with only one left like this. Before distributing it to the web, you can think of it as a step to reorganize the one that is currently uploaded. If the run is all running like this, you will see an icon called Setup Web Service on the right side of the run at the bottom. This icon can be used to distribute the model to the web. If you mouse over here, two things will appear. Among them, Predictive Web Service. If you click this, something magical happens on the screen. Please keep an eye on the screen. Did you see something change? When we do Predictive Web Service, the main difference is basically two tabs on the top. Previously, we trained in a training experiment. Click here. Everything we practiced remains the same. However, if you check the newly created predictive experiment, the model we trained was newly constructed in a form that can be distributed to the web. So, a new module was added at the top and bottom. There is a web service input on the top. There is a web service output at the bottom. Each is not the value we prepared as a CSV file, but it means that when this condition comes in from the web, we accept it as the web, and when the model receives the value, we can send the final output back to the outside. Then, you can deploy using this as it is, but a little modification is required. What kind of correction is needed? Let's go up again. If you look up, the web service input is connected here. It's not coming from here, but we modified the data. We did all the edit metadata. But it would be better to get the edit metadata in the same data format that we did all the edit metadata, instead of receiving the input in the first format. So, let's drag this blue web service input and bring it to the bottom. I'll bring it down like this. Bring the data down like this. Here's the score model. When we put new data into this score model, the model that was trained will make predictions with the data. So before, I put the data that passed edit metadata. But I will connect this web service input to the score model right away. If you connect it like this, the line connected to the top will be cut off. Edit metadata and web service input are connected at the same time. Isn't only one of the two connected? No, it's correct that both are connected. The reason why both have to be connected: when data is received from the web, it is decided in what data format it will be received. The edit metadata should be connected and the web service input should be connected. It is recognized that we are accepting data in this format from the web. Then, when we receive this data, we will evaluate it with the model trained here, and it is designated to give the result to the web service output. The shape of the model is different from before. Previously, it was a train model module, but now I packaged the model that has been trained in this way, so you can see that it has been transformed into something inside the box. After connecting the web service input with the score model, I will run the entire run again. When we distribute to the web, we no longer need split data. Since we don't need to divide the data anymore, you can see that the split data is invisible. You just connect well where you are going to receive only web service input. When the green check mark appears, you can click Deploy Web Service at the bottom to deploy it to the web in this form. When we distribute it on the web, we move to this screen. The regression Walmart modeling we created, this model will be accessible on the web. The key value you use at that time is displayed here. What this API key means: we shouldn't be able to approach all of our models and make predictions. So you can think of it as a key that you can have access to. So this key should be well secured. There is a blue button so we can test it later. If you click this, you can enter all the values of the store we have: date, temperature, fuel price, CPI, unemployment, department, issue ID, type, and size. Then, when you enter these values, you can check the predicted value of how much the model will sell. Shall we put the price? Oh, but here the other values are all good, but you can see that weekly sales are included. Weekly sales is a value we don't need to get when we enter. However, since weekly sales were included when we learned earlier, you can check that weekly sales are included in the input data even when deploying the web service later. It is possible to make a prediction right away with the value left blank here. But it would be cleaner as there is no item at all. So I'll do one more work to get rid of this. I'll click back. If you go back, you will see the same shape as before. What we want to do is exclude only one column out of all the columns we had earlier. Since weekly sales is a value that does not need to be entered, we will use the module we used before to exclude it. I'll select Columns in Dataset from Manipulation within Data Transformation. For Select Columns in Dataset, just leave the location around here. Please place the location between Edit Metadata and Score Data. Edit Metadata. Please connect the data up to here with Select Columns in Dataset. After that, connect the Select Columns in Dataset to the Score model again. Previously, Edit Metadata and Score model were directly connected, but a Select Column in Dataset was added in the middle. With Select Columns and Dataset selected, look at the property window in the right. Turn on the Lunch Column selector here. Then, here we have 11 columns, of which we will not use only one weekly sales. If you subtract one of this and send the remaining 10 to the right like this, it will be changed to a form where weekly sales are not received but only the remaining conditions are received when data. Check it out with 10 selected like this. Then I'll try the run at the bottom again. We do this because there is a difference between the form of data when training and the form of receiving data when distributing and using it on the web. So, if you work here, you can think that the data schema itself that we receive data changes. After all work is finished, click Deploy Web Service to the right of Run again. When you click on it, there is something already made, but you are prompted to override it. Click Yes to overwrite the existing one. Then the screen will pop up again. Clicking the blue button here brings up a window where you can predict the value. Here you can see that only 10 features are listed: store, date, temperature, fuel price, CP, unemployment, department, issue, type, size. Previously, it was obviously asked for weekly sales. But now you can see that it does not ask for weekly sales when receiving input values from the web. It's a little weird to ask for the value we want to predict from the beginning, so I subtracted it. Then, let's enter the desired values here. When you open the store, there are up to 45. There are stores from 1 to 45. Let's select store 21 and enter the date as October 3, 2020. And the temperature is about 70 degrees Fahrenheit. And the fuel price was about 3 on average before. Let's say that the price has gone up so much that it is about $10. And let's say that the CPI was 200. The unemployment was about 10. And the debt was not 12-ish a day. Then type in one of A, B, and C. B type. The size is about 15,000. In this case, let's make a prediction to the model how much the sales volume will be. Enter whatever value you want. Then press the check button at the bottom. And you can see the return value at the bottom. Let's zoom in. Then the regression Walmart model that we made returns. And the value will be displayed as the value we entered. After that, you can think that the last one is the sales. So, when this condition comes in, we can simply test here how much the model predicts. Then check the API value and when you want to actually use this model. You can select Request Response and access it using code. The URI that can access here is displayed here. You can access this model by using the API key value we saw earlier. And when we put values, we just need to put these values in store, date, temperature. If we want to test this with code, there is also some sample code that shows how you can access it in C or in Python or R, and get the result if you go straight down. So, if there is someone in our team who can use the code, or those who say that I can run it, you can use the code to access the model, pass the value, and receive the output. I don't have to worry too much for those who seem to be a little difficult to see code like this. Because let's go back to the previous page. If you turn to the previous page, you can access and use this model with code. Here's how to use Excel, which we are familiar with. If you click the Excel button, you can download a file that can use this model we have in Excel. I will open it once. I open the file I just downloaded from OneDrive. If you are using the latest version of Excel, you can use the machine learning service directly in Excel. Azure Machine Learning pops up here. When we click the regression Walmart modeling we learned, it loads. We can check what input value we have to put in and what comes out as the output. Then click Predict and click Use Sample Data to input sample data like this. We have to input where the input value is. So, the input is from here to here. Then click this button to enter the input value. Then, if I ask where to write the output, I will write the output in column K. Then, if you say you want to write from K1, enter it like this, and if you press Predict, you can see the values in each of the values here in the scored label that will come out when these conditions are met. So, we can write code and use this model in C, R, Python, etc. But you can confirm that these values come out under these conditions even by using the Excel program that we use frequently. How about, after making the model, you might have been wondering how to use it. If you use Excel, you can use the trained model without difficulty.